I'd like to walk through the Hydronautics 2015 software calculator for membrane treatment and kind of walk through the different aspects that you will need to use for your homework assignment. So we have some data that I've entered in here, so you can put in your project calculated by temperature and things like that. Let's go ahead and drop this down to maybe 50 degrees Fahrenheit for water. And so I've entered all the values into the cations and anions. Notice they can convert it automatically from milligrams per liter to milligrams per liter as CaCO3. That's there. And then if you want to balance the data set, I would definitely focus on either chloride, sulfate, something else that's in this anion list to get it balanced. And you'll see a warning. That you don't see the warning here, but you will see one. And you just click on the parameter and it will auto balance it. You'll notice that your milliequivalent should now be balanced with that, but your calculated TDS might be different than what you have reported from your water supply that we looked at in the homework assignment. That's okay. I mean, we're trying to balance this. I think the data set that we were provided from the South Dakota DENR was incomplete, and there could be errors with the measurements or analysis that's there. So once you get this entered, everything's good. Then you can click on to design up here, and we have this system. And so here's our pH, feed pH, permeate recovery. I put 90%, maybe we put 95%. It varies quite a bit depending on the membranes that you choose for this. Permeate flow, a little pull down menu. So I got million gallons per day. We want 6 million gallons per day is what we want to get out of the back end of this plant. The rest of these parameters are calculated based upon what you choose for your specific elements. So you'll see a yellow box here. Yours may just be blank. Got to make sure everything is designated first. Click on it and pull down menus is here. And we're just looking for a basic softening one. So we have all different types of element types. You've got the different gallons per day, salt rejection, area spacer, test pressure, and so on that is in this process. So I just went with this nanofiltration softening biostatic, and we can either have one or two. Let's choose this one here. Hit OK. And you can see the feed pressures that are there and the permeate TDS concentrations. Hit OK, and then it automatically adjusts and provides a number of arrays that you would need for this. So I'll hit recalc array just to make sure, and lo and behold, we need 90 vessels, 44 for the second pass. This is actually they're recommending multiple passes to get that treatment levels down to what we require or what they require, and then a third one. And then we've got different chemical additions that we can choose. Look at different aging. It's going to tell you how much chemicals you want to put into this. So for now, let's just leave this as none. This one doesn't actually use any chemical feed that's there. So now the next step is to hit run, and you'll see this floating diagram came up, but let's run it again just to make sure everything is okay. And so we have some data now that's here, and so we've got the arrays, the vessels, the feed PSIs. You'll notice it goes high pressure down to lower pressure, concentration, feed in gallons per minute that's coming into the plant, the flux, so gallons per foot square per day, highest flux and the highest beta values that are there. And here's the permeate concentrations. This is what we want. This is the concentrations of our anions, cations that are leaving the water filtration system. And we can also look at these other parameters. So we do have a saturation limit exceed, and so it looks like we're going to have some scalant that's that could be built up onto the perimeter or the periphery of the membrane, and probably would need to use a chemical anti-scalant that's on here. So it'll still run without that, but that Langelier saturation indices is quite high, and so we may want to consider putting that into our system. You can see a floating diagram, so this would be the diagram of how this system works. So we got our permeate passes through clean, a retentate, they take the retentate, pass it in again, and then squeeze some more out of it on the third pass here. And this total that's at number 9 would be our 6 million gallons per day of that system. And so we can go now to calculations, and we can see the different calculations that are here. This is kind of neat if you're going to do this in your professional world as you move on past the South Dakota School of Mines. You can look at, all right, here's the plant capacity, here's the investment, how much it would cost, and investment dollars, interest rates. So you could look at the long-term effects of this, and is it going to pay off to do this? Number of elements, how much the dosing acid costs, and these are all can be input parameters that will certainly change as the years go by. And so we have their cost calculate results. So the total water cost, this is quite impressive. So you can see the capital cost, that's US dollars per 10 to the 6 gallons. Power cost, actually quite low. Chemical cost is where it's really going to get you on this process, and so on. And so we've got the total water cost at about $61 per 10 to the 6 gallons of that system. You can go up here, look at chemical requirements and a summary of that, and you also have the power requirements. And so this is what I was asking for on the assignment, was the different pumping specific energy in kilowatt hours per cubic meter. It looks like I've got kilowatt hours per 10 to the 6 gallons, but you can change or calculate what that would be on a cubic meter stage. And so how much it would cost. And I believe if we go to, somewhere up here, we can go on to the different chemical requirements cost. Okay, and the power cost can be entered right here if you wanted to change that. So it looks like 15 cents per kilowatt per kilowatts is there. So you should have all the information you need for this particular project using this, and look forward to seeing how you might design the Rapid City water treatment plants and see if this is going to be more cost effective than using a basic lime and or soda ash softening plant. Thank you.